Okay, hi guys. So we're told to solve this question using Runge method instead. This is actually the same question I used to solve Euler, Cauchy, and analytical. When I use Runge now, we'll compare all the answers after this. So this is the formula for Runge and this is how to get K1 to K4. So now, remember this is x initial, which is 2. It was given. And then the step size is zero point 0.2. So x1 will be 2 plus zero point 0.2, which is 2.2. Then keep going to reach 3. We're stopping at n equals 5. The question can tell you to stop at n equals 2. It just depends. So now let's start solving. For n equals to 1, that's at this point, we want to find what y will be. So when x equals 2.2, what will y be? But now we're going to have here n equals to 0. At n equals to 0, we have that x naught is equals to 2 and y naught is equals to 5. So then here we're going to have that k1. We first solve for k1. So k1 is equals to 0.2 f of xn and yn, in this case 2 and 5. This is going to become 0.2 times 1 because if you put it into the equation, it will be 2, 1 plus x2 minus 5, which is equals to 1. So it's going to be 0.2 for k1. Then for k2, it's going to be equals to 0.2 f 2 plus 0.2 over 2, that is x of n plus h over 2, then comma y of n plus, in this case this is actually supposed to be k1 over 2. You can check the formula to verify. This is going to be equals to 0.2 f of 2.1 5.1. We put into the formula like we did this, we're going to get 0.2 times 1.1 is going to give you 0.22. So K2 is equal to 0.22. Now for K3, we're going to have 0.2 F2 plus 0.2 over 2, which is H over 2, comma K2 in this case, which is 0.22. Sorry, Y plus K2 over 2 is going to be 0.2 F 2.1 and 5.11, which is going to be equal to, you substitute this into the equation, then you multiply by 0.2, you're going to get 0.1218 actually. Then for K4, simply equals to 0.2 F xn plus h, comma 5, that's yn plus K3, which is 0.218, which is equals to 0.2 F of 2.2 and 5.218, which is equals to 0.2364. So now that we have k1 to k4, we can simply substitute back into the equation. It's going to be 5 plus 1 over, that's yn, which is in this case y naught, which is 5, plus 1 over 6. Then k1 is 0.2 plus 2 times k2, 0.22, plus 2 times k3, 0.218, plus k4, 0.2364. And this is going to give you 5.218733. Now moving on to n equals to 1. So for n equals to 1, you can have that x1 is equals to 2.2 and y1 is equals to 5.218733. So for k1, I'm going to be a bit more faster in my solving. So it's going to be 0.2 f 2.2 and 5.218733. So this is going to be equal to 0.236253. You substitute this into the function and then you multiply by 0.2. Then for K2, it's going to be equal to 0.2f xn 2.2 plus h over 2, then comma 5.218733, that's y1, plus k1, which is this, over 2. And that will be equals to 0.252428 if you simplify everything. You can use your calculator to verify the solving. Then this is going to be 0.2f 2. So this is going to be the same thing, 2 plus 2 plus 0.2 over 2, which is 2.3 basically. Then y1 plus k2 over 2. This is going to give you 0.251011 when you simplify everything. Then for k4, it's going to be equal to 0.2 f 2.4, because in this case it's x of n plus h, then y1 plus k1. So that's going to be equal to 0.266054. Calculation for y2 will be equals to y1 plus 1 over 6 k1. This should be equals to 5.470260 when it's put in your calculator. Now for n equals to 2, we're going to have the x2 is equals to and y2 is equals to. So for k1, you can have it as 0.2 f 2.4 5.470260, which is going to give you 0.265947. For k2, we're going to use the same formula 0.2 f 2.5, because in this case it's 2.4 plus 0.1, that's 0.2 plus this as according to the formula, which is going to total, it's going to give you 0.279353. Then for k3, we're going to have 0.2f 2.5. This 2.5 was gotten the same way, 2.4 plus 0.2/2. This is going to give you 0.278012. And then for k4, you're going to get 0.2f 2.6. This is going to be 2.4 plus 0.2, that's plus h alone. And then y2 plus a3 is going to give you 0.290345. So now y3, using the same formula from before, is going to give you 5.748767. So now for n equals to 3, x3 is equals to, and y3 is equals to. So now for k1 again, we're going to have 0.2 f 2.6, and this is going to give you 0.290247. For k2, we're going to be given 0.2 f 2.7 5 points. Now this is 2.6 plus 0.2/2 from the formula, and this as well is also from the formula. So to give it 0.301222. Then for k3, we're going to have 0.2 f 2.7, same I got this, and this is y3 plus k2/2 to give you 0.300124. And then lastly for k4, this will be 0.2 f 2.8 is simply x3 plus h, then y3 plus k3, which is simply going to give you 0.310222. Now for y4, you're going to have the answer 6.049294. Now for yn equals to 4, this is the last one. x4 is equals to, and y4 is equals to. For k1, it's going to be equals to 0.2 f 2.8. Solve this and you're going to get 0.310141. For k2, it's going to be equals to 2.9, because it's going to be 2.8 plus 0.2/2. Then y4 plus k1/2. This is going to give you 0.319127. K3 is going to be equals to 0.2 f 2.9. The same way I got this. Then y4 plus k2/2. This is going to give you 0.318228. And then for k4, it's going to be equals to 0.2 f. It's going to be 2.8 plus h, which is simply 3.0, then 6. Then y4 plus k3 is going to give 0.326496. Now y5, when you put it into the equation, is going to simply give you 6 plus 3 6. It's simply going to give you 6.367852. Now let's compare it to the other answers we got. Comparing it, you can see that Runge is actually way closer to the analytical method, which is the most accurate than even Euler culture or so. Thank you for listening, and I hope you really understood.